Question 3. Now we have a graph, and part A is asking us to find the coordinates of A and the coordinates of B. Well, from the graph we can see that is where f of x equals 0, where the graph equals 0, so f of x equals 0. And so going back to the equation, 8 minus x ln x equals 0 at A and B. The expression's already factorised, so I have either 8 minus x equals 0, in which case x equals 8, and so coordinates are 8, 0, or ln x equals 0, in which case x equals 1, 1, 0. Now although it's only a sketch, looking at the graph those answers do seem to make sense in time with the sketch. Part B is asking us to find f dash x. Well, f of x equals 8 minus x ln x, so I have a product here, u and v, so f dash x equals 8 minus x times the derivative of v, which is 1 over x, plus ln x times the derivative of 8 minus x, which is minus 1. So I can tidy that up, 8 minus x, 1 over x, minus ln x. And that runs into part C, which is showing that the x coordinate of Q lies between 3.5 and 3.6. Well, at Q it's a turning point, it tells you getting a question, so at Q f dash x equals 0. So 8 minus x, 1 over x, minus ln x equals 0. Okay, so as I've been doing before, I'll plug those values into the calculator. I won't bother to show it this time, but f dash 3.5 is approximately equal to 0.033, and f dash 3.6 approximately equal to minus 0.059. So that shows us that between 3.5 and 3.6 we have a sign change, and from the graph as well as the function itself we know the function is continuous in this range, and so therefore gradient is 0 between these values. Part D is show that the x coordinate of Q is a solution to the formula they give you there. We know at Q f dash x equals 0, and so 8 minus x times by 1 over x minus ln x equals 0. Now we're trying to get it into the form x equals 8 over 1 plus ln x. So I'm going to expand out the brackets on the left hand side, so I get 8 over x minus 1 minus ln x equals 0. Going to bring the 8 over x on its own. 8 over x equals 1 plus ln x. And now I'm just going to swap the x and the 1 plus ln x. So I end up with x equals 8 over 1 plus ln x, which is where we want to be. Okay, E now is getting a numerical approximation. And we're going to use the formula that we've just got. So this one here. And we're going to have x naught equals 3.55. And we're trying to find x1, x2 and x3. So into the calculator for this one. First thing I'm going to do is define x, 3.55 equals, store x. And next I'm going to put in that formula. So 8 over 1 plus ln x. Okay, so I've got 3.55 stored. First run through gives me 3 point, and how many to go into 3 decimal places? 529. And I'm going to store that now as x. Back up to the formula. Second run through 3.538. Store that as x. And my final run through 3.5. Oops, sorry. 3.4 to 3 decimal places.